Welcome in the subject of mechanical system design. I am Professor A.P. Godke, assistant professor in mechanical department. So today we will learn the design of a belt conveyor system for material handling. So belt conveyor system, it is the mechanical device used to transport the material from one place to another place for a certain length. So the conveyor is a system, a common piece of mechanical handling equipment that moves material from one location to another. Conveyors are especially useful in application involving the transportation of heavy or bulky materials. So the conveyor system allow quick and efficient transportation for a wide variety of materials, which makes them very popular in the material handling and packaging industries. A conveyor belt is carrying a medium of a belt conveyor system, often shortened to belt conveyor. Next is what are the different types of conveyors that can be used to handle the materials. So here you can see the various types of conveyors. So first is a belt conveyor system. Next is a flexible gravity conveyors, roller conveyor system, screw conveyors, trolley conveyors, reciprocating vertical conveyors, vertical lift conveyors, pneumatic conveyors, vibrating conveyors, and bucket conveyors. So these are the various types of conveyors that can be used for the handling of the material. Next is the design of belt conveyor. So what are the design consideration and design parameters that are very important? So here in diagram you can observe the two types of pulleys are used in the conveyor. That is one is a head pulley and second one is a tail pulley. Then adjustment for conveyor alignment is located here. Then you can see the frame to support the entire parts of the belt conveyor. Then you can see the idlers, so that is the carrying run idlers and return run idlers to support the conveyor. So this is the construction diagram or various components present in the design of conveyor belt. So the design consideration are first design consideration is the designing the system for continuous flow of material. That is idle time should be 0. Then second consideration is going into the standard equipment which ensures a low investment and flexibility. Then third design consideration is incorporating gravity flow in material flow system. And last one is ensuring that the ratio of the dead weight to the payload of material handling equipment is minimum. So these are the four important basic consideration in the design of the material handling equipments or belt conveyor. Next is the design parameters for the design of the belt conveyor. First is the belt dimension, capacity, and speed of the belt. Then second one is the roller diameter. That is nothing but carrying rollers and return rollers are there. So the diameter is also important. Third one is the belt power and tensions. Next one is the idler spacing. Then a pulley diameter, that is a head pulley and tail pulley, or a driving pulley and driven pulley. Then motor is also important parameter. That is what is the capacity of the motor. Then shaft design is there, and then control units are there. So these are the different design parameters are considered for the belt conveyor design. Next is a belt dimension, capacity, and the speed. So the diameter of the driven and driver and driven pulley is determined by the type and dimensions of conveyor belting. The diameter of the pulley must be designed such that it does not place under the stress on the belt. The length of the belt conveyor is in meters, is the length from the center of the pulley parallel to the belt line. Then belt length is dependent on both pulley diameters and center distance. Then capacity is the product of speed and belt cross-sectional area. Generally, the capacity of belt cross-section is given by BC is equal to 3.6 AV rho, where A is the sectional area in meter square and rho is the density in kg per meter cube, while V is the belt speed in meter per second. So by using this formula, 3.6 A into V into rho. By using this formula, we can calculate the capacity of the belt conveyor in kg per second. Next, roller diameter. The roller supports the belts and facilitate the easy as well as a free rotation of the belt conveyor in all directions. The correct choice of roller diameter must take into consideration the belt width. The relation between the maximum belt speed, roller diameter, and the relative revolution per minute is given as n is equal to v into 1000 into 60 by dx, where small n is the number of revolution per minute, d is the roller diameter, and v is the belt speed. Next is the calculation for the belt power and tension. So the longer the length of the belt, the more the power required for the conveyor and higher the vertical distance of the lift. The higher the magnitude of power required, the power P at drive pulley drum is P is equal to F into V by 1000. So by using this formula, we can determine the belt power, that is P is equal to F into V by 1000. So here F is the total tangential force at the periphery of the drive pulley in Newton. V is the belt speed, that is will be 1.25 meter per second. Then the power required for the conveyor to produce the lift can also be calculated as P is equal to C into L into 3.5 divided by 1000. So the P is the power required for the conveyor in kilowatt. C is the conveyor capacity, that is will be the 355 tons per hour, is equal to 98.6 kg per second. And L is the lift, that is a 10 meter, and P is equal to the 3.7 kilowatt. Then the belt tension at a steady state is given as TSS by using this formula. So belt tensions can be calculated by using this formula, that is 1.37 into F into L into G into 2 times Mi plus 2 times MB plus mm cos theta plus H into G into mm, where TSS is the belt tension at steady state, F is the coefficient of friction, capital L is the conveyor length, then G is the acceleration due to gravity, Mi is the load due to the idler, MB is the load due to the belt, mm is the load due to the conveyed material, and theta is the inclination angle of the conveyor, H is the vertical height of the conveyor, and therefore TSS will be equal to the 71 kilonewton. That will be belt tension is equal to the 71 kilonewton. Then during the start of the conveyor system, we can also calculate the belt tension by starting. That will be the TS is equal to TSS into KS, where KS is the startup factor. So in that way also we can calculate the starting tension, that will becomes as a 76.68 kilonewton. Then idler spacing, so the idlers are installed at a graduated spacing to ensure that the sag as a result of the load varies inversely with the tension in the belt. An idler spacing of 1 meter is recommended for the belt conveyor system conveying a material of 1500 kg per meter cube material on the belt width of the 1200 mm. Then pulley diameter, the pulleys are manufactured in a wide range of sizes. The selection of pulley take into account the wrap angle 180 degree, then belt speed 1.5 meter per second, then method of belt strain, belt tension T, and belt width 1200 mm, then the type of the splice of the conveyor belt. Therefore, the pulley wrap length at the terminals is equal to 2 pi into D. Then the motor, the minimum motor power for sizing the motor is a P minimum is equal to PP upon efficiency. Though the P minimum is the minimum motor power in kilowatt, PP is the power at drive pulley, that will be 3.62 kilowatt, and eta is the efficiency of reduction gear 0.9. Therefore, P minimum will be equal to the 4.022 kilowatt. To determine the motor horsepower, we have a horsepower minimum is equal to horsepower required divided by efficiency, where horsepower required is calculated by horsepower HPE plus HPM plus HPJ, where HPE is the horsepower required to drive the conveyor empty. Then HPM is the horsepower required to move the material horizontally, and HPJ is the horsepower required to evaluate the material. Then shaft design, the shaft design consists of a primarily of the determination of the correct shaft diameter, that will ensure the satisfactory rigidity and strength when the shaft is transmitting the motion under the different operating and loading conditions. The values of the belt width and pulley diameters helps in selecting the size of the diameter from different conveyors and book. So next one, last one is the control, that is the compact programmable controllers, otherwise known as application controllers, can be used for control of the system. These controllers can be used for the time control and supervisory function as a conveyor speed control, then speed control of individual drives, speed and belt slip control, then load equilibration between the two driving drum and speed uh, difference control two motor on a driving drum. So in this way we can design the different parameters in the belt conveyor design. Then finally we have a limitations and conclusion of the belt conveyor system design. So the construction of a belt conveyor system requires high capital base. This is a major constraint that limit this work to design only, and such a performance evaluation cannot be carried out on the belt conveyor system. However, the research work provides the design data for the development of the belt conveyor system for industrial uses. The belt conveyor system is designed with a high degree of automation, loading, movement, and unloading efficiency. Therefore, it is the also very flexible shape with a low initial operational and maintenance cost while eliminating repetitive short distance movement in the manufacturing industry. So thank you for watching the topic design of a belt conveyor system.